In this video, our purpose is to name acids and write formulas for basic acids. To begin with, you need to be able to identify that you have an acid. One way is like going from the definition is that a hydrogen is a chemical species, a molecule, or an ion that's able to give up a proton. If it can give up a proton, it must mean it's got to have a hydrogen in there somewhere. So acids typically have hydrogen in them. I guess all acids, I hate to say all, but acids, we'll say acids have hydrogen in them. But not all molecules with hydrogen are acids. For example, here's an example of an acid. HCl is an acid, but CH4 is not an acid. Or C6H12O6, glucose, is not an acid. So you have to be able to identify which thing that has a hydrogen in it is actually an acid. Here's maybe just a quick little exercise that I can demonstrate that. So here, this one is an acid: nitric acid, sulfuric acid, methane's not an acid, hydrochloric acid, ethane's not an acid. Water, it has a hydrogen and it can give up that hydrogen. So in some cases, water can be considered an acid. NH3, not an acid, it's a base. If you take a look at these acids versus these non-acids, is there anything that sort of stands out? One thing for me is that with these acids, typically the hydrogen's written at the start. It's not always true, but it could be one way that you could spot an acid, whereas these hydrogens are written at the end. One of the exceptions, or I guess there's a couple of exceptions to that, is typically for vinegar or acetic acid, we write it like this, but in this case, the hydrogen's written at the end. Anyway, there'll be a little bit of trying to find or determine which is an acid and which isn't, and that's an important thing. You can use your data booklet. It often will have the formulas for the acids written, and that can help you spot them. Let's look at naming them. Here's a bunch of names of common acids. So sulfuric acid, sulfurous acid, hydrosulfuric acid, etc. In here, there's 3 rules that we can use to help identify an acid. And those rules depend on the anion name. Anion referring to the negative ion, and it's always the thing that's hooked up with the hydrogen. So if you look in your polyatomic ions, SO4, the name for that is sulfate. Okay? Name for this one is sulfite. If you look up SO3, 2 minus, it's sulfite. This one, it's just a sulfur, so its anion name would be sulfide. Here again, this one would be chlorate. This one's chlorite. Chlorite, and this last one is chloride. I missed an L. Okay, notice that the anion names end in one of 3 things, either an ate, an ite, or an ide. If they end in an ate, then your acid name becomes, you just change the ate to an ick and put an acid at the end. Notice there's no hydro in front of that. Not all acids have a hydro in front. So the rule is if it ends in an ate, you just change the ate to an ick and call it an acid. So the sulfate, it'll be, because there's a hydrogen there, this will become sulfuric acid. Let's see if there's another 8. Here's another 8. So this one here, it's an 8. It'll become, instead of chlorate, it'll become chloric acid. Okay, so that's one of the rules with the 8. If it ends in an ite, the anion name, then it's similar to that, but instead of saying sulfuric acid, we say it's sulfurous acid. Again, here's another ite, and again, here's the same rule. Instead of chlorite, it's chlorous acid. Lastly, if it ends in an ide, the anion name, and notice the ones that end in ide are ones that don't have oxygen. Lots of acids do have oxygen in them, but some don't. If they don't have an oxygen, they're going to end in an ide. And if they end in an ide, then you have to do 2 things. Change the ide to an ick, and you have to attach a hydro at the start of it. Okay, so let's put those rules together. So if the anion ends in an "ide," that's the last one we did, we change the name, we put a hydro in front of it, and we lop off the "ide" and put an "ic" there. For example, if I had HF, okay, F, the anion name for that would be fluoride. If it ends in an "ide," right here, change it to a hydro and put an "ic" on it. So HF, if that's an acid, it'll be called hydrofluor, and then change the "ide" to an "ic," hydrofluoric acid. Okay, if the anion ends in an 8, then you just switch the 8 for an "ic," and it'll be that kind of acid. So say if I had HNO3, NO3, that anion name is nitrate. So if it's nitrate, like this one, notice there's no hydro in this one. I just change the 8 to an "ic." So this would be nitric acid. And finally, if the anion ends in an "ite," then change the "ite" to an "us" acid. All right, let's try a couple. Yeah, I got that. Let's try a couple. So here's a few names that we can use. Here's our rules up here, so we can use the rules. Maybe just pause and see if you can come up with the acid name for each of these using these rules. Okay, I'll do them too, but maybe pause, try them on your own, and then press play and I'll go through them. First one, this ends in an "ide." Okay, the anion is chloride, so the acid name will be "ide." It has to change to a hydro. So it'd be hydrochloric acid. Next one, 8. SO4 is sulfate. It ends in an 8. So that's this rule. I just change the 8 to an "ic." So this one will be sulfuric acid. Okay, because that one ended in an 8. NO2, look up the chart, that's an "ite." So if I look up "ite" right here, just change the "ite" to an "us." So this would be, instead of nitrite, it'll be nitrous acid. Another one, CN, look on your periodic table, that's a hydrogen cyanide. If it ends in an "ide," my rule is to get a hydro. So hydro, and change the "ide" to an "ic." So not cyanide, hydrocyanic acid. Two more. PO4, that's phosphate. It ends in an 8. My rule for 8 is right there, so I just changed the 8 to an "ic." So instead of phosphate, it's going to be this is one where we sort of throw something else in there, phosphoric acid, just to make it sound more chemical-ish. And so instead of calling it phosphic acid, we'd call it, yeah, that should be an O, phosphoric acid. Okay, last one, ClO2. ClO2, I think off the chart, is chlorite. If it's an "ite," I look up here, change the "ite" to an "us. So this would be chlorous acid. Again, notice that not all of them have a hydro in front. The only ones that have a hydro are ones whose anion name ends in an "ide." Let's go the other way. So here's the names. Now I want to come up with the formulas for each one of those. Again, pause, try it on your own, then press play, see if you get the right answer. Okay, hydrosulfuric, so it's hydro and an "ic." There's a hydro-ic. It must have come from an "ide." So this one must be a sulfur, just a sulfur by itself. But then I have to figure out how many hydrogen. I know I have to put a hydrogen here, but I have to figure out how many hydrogens I need to put there. To figure that out, what you do is look at the charge of the sulfur. So if the sulfur is a 2-, each hydrogen is a 1+, so to balance out this acid, I need 2 of these hydrogens. So I'd put a 2 there. So hydrosulfuric acid is H2S. Okay, sulfuric acid, sulfuric, there's no hydro, so it has to be this one. Has to have come from an 8. So this one has to have come from an 8. Here's 8, SO4. But SO4 is a 2-. I know with all acids I need a hydrogen in them. Since they're 1+, This is a 2 minus. I need 2 of those. So sulfuric acid, H2SO4. Sulfurous acid, us must have come from ite. Sulfite is SO3. It's also a 2 minus, so that means I need to have 2 hydrogens in there. Notice I'll put those charges in there, but they're not part of the formula. I should erase them later. I just need that charge to figure out how many hydrogens I need to put with it. Okay, hydrobromic acid, there's a hydro and an ic. Here's hydro and ic, must have come from an ide. So this must have come from bromide. The bromide ion is a negative. There's only one negative, so I just need one hydrogen to hook up with that. So hydrobromic acid, HBr. Dichromic acid. Okay, dichromate, if you look at that on your chart, is Cr2O7. Its charge is a 2 minus, therefore it's an acid, so it needs hydrogens. And since this is a 2 minus and hydrogen is a 1 plus, it needs 2 hydrogens. So H2 Br or H2Cr2O7, that's dichromic acid. Last one, nitrous acid. Us comes from right here, must have come from an ite. I look up the chart to see which one is an ite. Ite is NO2. Its charge is a 1 minus, so I just need 1 hydrogen to balance that off. So its formula is HNO2. Okay, hopefully that's given you some practice in naming acids.